In 1859, telegraph operators reported strange behavior. Their equipment was working without being plugged in. Papers were catching fire spontaneously. The night sky glowed bright enough to read by, from Cuba to Hawaii. This wasn't magic, it was the sun, and if it happened today, modern civilization would collapse in 8 minutes. On September 1st, 1859, astronomer Richard Carrington was observing the sun. He witnessed something unprecedented, a massive white light flare erupting from the sun's surface. 17 hours later, Earth's magnetic field went haywire. Telegraph systems across North America and Europe failed. Operators received electric shocks. Equipment burst into flames. The aurora borealis appeared as far south as the Caribbean. People in the Rocky Mountains woke up at 2 a.m. thinking it was dawn. The entire planet's magnetic field was being bombarded. This was the most powerful solar storm in recorded history, the Carrington Event. And here's the problem. In 1859, we had telegraph lines. That was it. Today, we have power grids, satellites, GPS, the internet, and communication networks, all of it vulnerable. A solar flare is an explosion on the sun's surface, caused by magnetic field lines tangling and suddenly releasing energy. A typical flare releases the energy of millions of nuclear bombs. A super flare? 1 billion times more powerful. When it erupts, it hurls a massive cloud of charged particles toward Earth. This is called a coronal mass ejection, or CME. It travels at millions of miles per hour, and when it hits Earth's magnetic field, everything changes. The impact creates geomagnetic storms. Electrical currents surge through power lines. Satellites get fried by radiation. GPS signals scramble. Radio communications black out. And we get exactly 8 minutes of warning. That's how long it takes light from the sun to reach Earth. When you see the flare, it's already on its way. But here's what scientists just realized. We were lucky in 1859. The next one might not miss. On July 23, 2012, something terrifying happened, and almost nobody knew about it. A Carrington-class solar storm erupted from the sun. Massive, powerful enough to send us back to the 1800s, but it missed Earth by 9 days. 9 days earlier, and Earth would have been directly in its path. Scientists didn't realize how close we came until years later. When they analyzed the data, they were shocked. Daniel Baker from the University of Colorado said if it had hit, we'd still be picking up the pieces. The economic damage would have exceeded $2 trillion. Power grids across entire continents would have failed. Transformers destroyed. Satellites permanently disabled. And here's the disturbing part. The sun produces Carrington-level storms every 150 years on average. The last one was 165 years ago. We're overdue. In 1859, the impact was limited. Telegraph systems failed, but civilization continued. Today, everything runs on electricity. Power grids, water treatment plants, food distribution, banking systems, communication networks, GPS for navigation, the internet. And here's the problem with power grids. They're all interconnected. A surge in one region cascades to others. Transformers aren't designed for geomagnetic storms. They overheat, they fail, and they take months to replace. Each transformer is custom built. You can't just pull one off a shelf. During the Carrington-level event, thousands would fail simultaneously. From video number 2, you know Earth's magnetic field is weakening, 9% loss in 40 years. That means less protection from solar storms. We're more exposed now than we were in 1859. And the sun isn't stable right now. We're entering solar cycle 25, the active phase. The sun operates on an 11-year cycle, solar minimum to solar maximum. During solar maximum, flares and CMEs increase dramatically. We're heading into that period now. Solar cycle 25 began in 2019, will hit maximum around 2025, right now. And this cycle is more active than scientists predicted, already producing stronger flares than expected. The National Oceanic and Atmospheric Administration tracks this. They issue space weather warnings, but warnings don't stop the impact. If a Carrington-class CME launches toward Earth today, we'd have 8 minutes to see it, then 15 to 18 hours before impact. Not enough time to shut down power grids safely, not enough time to reposition satellites, not enough time to prepare infrastructure. And if it hits at night, when demand is low and systems are vulnerable, the damage would be catastrophic.
The first thing you'd notice is the lights going out. Not just your house, entire cities, regions, countries. Within hours, backup generators run out of fuel, hospitals lose power, water stops flowing. Without electricity, pumps don't work. Food in stores spoils within days. Gas stations can't pump fuel. ATMs don't work. Communication networks collapse without power. No internet, no phones,